Here we have Hess's Law presented by Lorena Diosdado. So there are actually two versions for Hess's Law. We are going to start with version number 1. So with version number 1, what you're going to do is that you're going to add the given reactions that were given to you so that they can cancel out to get the reaction that they want you to find. So whatever you do to the given reaction, you need to do as well to the delta H. For example, if you reverse the given equation, you need to change the sign of delta H. So if you change the order of the products and reactants around, then your delta H will either become positive or negative depending on what the opposite of it was originally. If you multiply the given equation by a number, then you need to multiply delta H by that same number. So say you're going to multiply your equation by 4, then you need to multiply your delta H by 4 as well. So at the end, if the solution is a multiple of the equation you're trying to find, then what you do is you divide by that factor, remembering to divide the delta H by that factor as well. So for example, if you are trying to find A plus B to yield C, and the solution you get ends up being 2A plus 2B yields 2C, and your delta H for that is 20, then obviously all you need to do is divide by 2 to get A plus B yield C, and then your final answer would be a delta H equal to 10. So here we have what we're trying to find, and then 3 given reactions. So what we're trying to find is E yields 3D plus C, given that you have 2A plus C yields half of B with a delta H of 5 kilojoules, and you have 3/2 B plus A yields 3D with a delta H of negative 15 kilojoules, and 4A plus 4C yields E with a delta H of 10 kilojoules. So the first thing we're going to do is we're going to reverse the equation at the bottom. That way we get E to the left-hand side, which is where we want it. And in doing that, then we're going to turn our delta H into negative 10 as opposed to positive 10, remembering those rules to flip your sign around. And the next thing we're going to do is we're going to multiply the top equation by 3. That way we get 3/2 for B, remembering to do that to delta H as well. So our delta H is going to be 15 now. Okay, so here we have our B's canceling out completely since they are on opposite sides of the equations and that they are equal to each other. After that, we're going to be able to cancel out our C's as well, leaving only one C on the right-hand side, which is what we need. Okay, so now it's pretty obvious that we have found E yields 3D plus C. So now we need to calculate our delta H. So we're going to take our 5, multiply that by 3, subtract 15 from that, and then subtract 10 from that. So that's going to be 15 minus 10, and that's going to give you negative 10 kilojoules. Here's another example. You have 2C plus H2 yields C2H2, and given the reactions C2H2 plus 5/2 O2 yields 2CO2 plus 2H2O, and that's going to be a delta H of negative 1299.5 kilojoules. And then we also have C plus O2 yields CO2 with a delta H of negative 393.5 kilojoules. And lastly, we have H2O plus 1/2 O2 yields H2O with a delta H of negative 285.8 kilojoules. So the first thing we're going to do is we're going to reverse the top equation, remembering to change our sign for our delta H to positive 1299.5 kilojoules. And then we're going to multiply our middle equation by 2, remembering to multiply our delta H by 2 as well. And by doing that, we can cancel out our H2Os. And then we can cancel out our CO2s. And then we can cancel out those O2s. And we're left with your 2 C's and your H2s to get your C2H2. And so then we're going to use those numbers to get our delta H. So 1299.5 minus 393.2, 393.5 times 2 minus 285.8 to yield negative 226.7 kilojoules. Remembering that I changed that first number to positive instead of a negative, since we'd reversed our equation. Okay, so now we're going to do version 2 of Hess's Law. And by doing that, you're going to take the sum of the products minus the sum of the reactants, and that's going to give you your delta H. So to do this, you're going to be given the enthalpy of formation for each compound, which you will plug into the previous equation right here. So note, elements by themselves will always be equal to 0. No exceptions to that. And that is due to the fact that there's no enthalpy of formation between an element that is itself, because they essentially just kind of exist together. There's no actual formation between them. So here we have C3H8 plus 5O2 yields 3CO2 plus 4H2O. And these are the numbers that are going to be given to you. So you're going to have negative 104 for formation, remembering that O2 is an element by itself, so that's going to be equal to 0, and then negative 394 and negative 242. You need to carry down those coefficients, so it's going to be 3 times negative 394 and 4 times negative 242. Notice I did not bring down the 5 because obviously 5 times 0 will give you 0. And right now we're going to take the products and then we're going to subtract the reactants from that. So it's going to be negative 394 times 3 minus 242 times 4, all minus negative 104. And so that's going to give you a total of negative 2,046 kilojoules as your answer. Here we have another equation. NH3 plus HCl leads to NH4Cl. Once again, these are going to be given to you. So negative 46 is the enthalpy of formation, negative 92, and negative 314. So it's going to be your products, negative 314, minus your reactants. And our reactants are negative 46 and negative 92. And that's going to give you a total of negative 176 kilojoules as your final answer. Okay, so I hope that was helpful, and thank you for watching.